Okay, let's go to the next example, problem number 2, or illustrative problem number 2. A solid wood cylinder of specific gravity 0.6 is 600 millimeters in diameter and 1,200 millimeters high. If placed vertically in oil, which has a specific gravity of 0.85, would it be stable? So let's try to illustrate the problem here. Okay, so this is the cylinder. It would be placed vertically. So, yan. Ibig sabihin yung, basta ganyan, yung longer vertical, yan. Mas mahaba nasa upright. Vertical yung mas mahabang side, okay, ng cylinder. Okay, so that's it. So our initial assumption is that M is higher than G. We will discover later if that is true. So based on our figure, M is higher than G. We'll try to discover that later. Okay. So again, para malaman natin if stable or unstable yung solid wood cylinder, we need to solve for MBO and GBO. Ayan, pag-ulit lang. Solve lang natin yung MBO and GBO. So first, we need to solve for the draft or the depth of flotation D by virtue of the principle of buoyancy. Okay, so we know that BF is equal to the weight. Then we'll try to expand this equation. BF is gamma of oil times the displaced volume. Since the liquid is oil, yeah, gamma of displaced liquid times the displaced volume. Expanding this term further, gamma of oil is equal to gamma of water times specific gravity of oil times the displaced volume, which is equal to, so area of the base times height. So area nitong base niya, which is circular, so pi d squared all over 4 times d. So we are solving for the draft. Ayan. So in terms of d dapat ito. And then the weight of cylinder, so gamma of cylinder, which is wood, and the volume of the cylinder. It's equivalent to gamma of water times specific gravity ng wood times the volume, so area of the base times height. And then equate the two forces, so yeah, the buoyant force and the weight. Since it's a floating body, they are equal. Cancel yung gamma ng water. We're left with D. Okay, cross multiply lang natin. And then D is equal to 0.847 meters. So that's the depth of flotation or the draft. Okay. Then by inspection, how do you solve for GBO again? So yung center of buoyancy is the centroid of the displaced volume. So if this is the displaced volume, okay, so the centroid then is d over 2 from the bottom or d over 2 from the liquid surface. Yan. So, and G of course is, wala namang sinabi na kargado. Yan. So basically, ang center of gravity nito is exactly the center or the centroid of the shape or the solid. Ayan. So G is equal to, if this is 1,200, so divided by 2, that is 600 millimeters. So basically, to solve for GBO, that's G, or 600 millimeters minus D over 2. Ayan. So by inspection, L over 2, GBO is equal to L over 2 minus D over 2. So L over 2 minus D over 2. So L over 2, 1,200 over 2, which is 600, minus D over 2, D na solving kanina. Okay? So GBO is equal to 0.1765 meters. Next is to solve for MBO, distance between the metacenter and the center of buoyancy. So we cannot use the formula for rectangular section. So basically, we're going to use the general formula. Okay, so MBO is equal to I all over the displaced volume. Ayan. So again, yung I dyan is the moment of inertia of the cut section here. So if this is the liquid surface, yung na-cut niya, so baliktarin mo yan. So basically, it's a circular section. Circular yan. Okay, so yung moment of inertia niyan, ilalagay natin dito sa formula. So pi r to the fourth over 4. The radius is 3, since the answer is 6, 0.6 I should say. All over displaced volume. So we can now solve for displaced volume since we have solved for the draft a while ago. So pi d squared over 4 times yung draft natin. Ito lang naman yung displaced volume, diba? So hindi yung L or yung total height. Ito lang yung draft. Okay, so MBO is 0.0266, which means that MBO is less than GBO, therefore the cylinder is unstable. Pag sinabing unstable, so mag-tip over yan. So mag-roll over yan dun sa oil. So hindi siya mag-float sa ganitong position since M is lower than the center of gravity. Okay, so that's for the second example. For the third problem, we will have a separate video. Okay, so thank you.